everyone. I'm Arjun Chandar, CEO of IndustrialML. And I'm here today with one of my old professors, Dr. Dave Hardt from the MIT Master of Engineering in Advanced Manufacturing and Design program. I'm looking forward to talking to Dr. Hardt today about the principles of manufacturing, how industrial IoT platforms and other technologies can help augment them, and where a lot of industrial IoT companies currently fail in implementing them and how they can do better. So Dr. Hardt, thanks for joining me today.
My pleasure.
So before we delve into things too much, would you like to let the audience know a little bit more about your background?
Sure, I'll very briefly. I'm a professor of mechanical engineering at MIT. I've been teaching in that area for quite some time, and my focus has been on manufacturing, and with an emphasis actually initially on control systems and more recently on statistical methods related to that. Through my involvement in manufacturing, I got involved in a number of industry-related research projects as well as educational programs, which eventually led to this Master of Engineering degree that Arjun just mentioned. We are currently, in addition to that, executing an online version of a subset of the subjects that we developed for that program, which is what we call the principles of manufacturing. Arjun and I worked together for quite some time when he was a student here, as well as after he left and went into industry. And I watched with interest as he developed this idea, which is now industrial ML. And Arjun, maybe you could tell us a little bit more about what that is.
Yeah, absolutely. So as a refresher for my audience, Industrial ML is an enterprise data platform which is built for factories. And we do everything from data integration to data analysis and data display, messaging, real-time alerts, and reporting. Ultimately, the purpose of doing all of this work is to make factories more efficient, not just in terms of how they plan their operations, but in terms of how they identify problems as they occur on the production line and how they're able to fix those problems. I'd say some of the things that set us apart, for instance, are that we specifically designed our platform for multiple stakeholders, including operators on the production floor, which is not a very common thing in our industry. Very often, machine learning and the data analysis platforms are heavily built for the data scientist class of stakeholders, I would say, or more specifically for the manager type persona. But we want to be able to cater to the broadest number of stakeholders, in particular the ones who have the most ability to affect change in factories, and that is what our platform is designed for. We've started out with our first development partner in the steel tube manufacturing space. And a lot of our early work caters very well towards continuous manufacturing in particular. But we've designed our platform to be applicable to a broad swath of the manufacturing industry. Dr. Hardt, I know that when in your intro, you talked a little bit about the principles of manufacturing, and obviously you and I have talked about that in private a lot, but for our audience, could you explain a little bit about what the principles of manufacturing are and why it is that the MIT manufacturing program elects to teach it that way?
So I'd like to tell you that we sat down in a room for a few days and a vision came from on high that we said, there are the principles of manufacturing. But in fact, they were something that emerged from our program, the Master of Engineering program, and its precursors, as we were trying to decide how best to prepare students for a significant career in manufacturing. And what we found was that the curriculum that we developed was appealing primarily to engineering undergraduates who had been out for a short period of time with a strong interest in manufacturing. But really we're not aware of the difference between sort of the idealistic view that you have of the engineering world as an undergraduate and the realities of manufacturing. And it really made us focus in on a set of topics that seemed to be succeeding in taking students to that new step. So it was more a matter of watching our students develop and see them working in the industry projects that are part of our program, as well as they leave and go off into industry. That's a long way of saying that we found that our curriculum was actually divided into two parts. One, which I'll call the technology of manufacturing, processes, automation. It could be things related to even design and things related to data science. In other words, tools, technological tools that change over time and have improved over the decades. There are some unchangeable things that seem to be part and parcel of any manufacturing operation, regardless of what it makes, what the technology is, what industries it in. And that's what we think the principles really get to. And it breaks down to some fairly well-known topics, actually. One is at the process level, which would be process control and quality, things of that nature. One is at the factory level, so we'll call it factory systems analysis and design. The next is sort of the external factory, otherwise known as the supply chain, bringing things in and out and moving things through the supply chain. And finally, those aspects of business that are most relevant to and driven by the needs of manufacturing. Now, as we took those topics, we also realized there were maybe two things that distinguished it from other technical realms, and I think it's particularly relevant to the types of things that industrial ML does, and that's what we affectionately call flow and variation. And what distinguishes manufacturing is the flow of materials, the flow of information, and the flow of capital and other resources that you don't find in many other engineering encounters. So that flow brings with it then the opportunity daily, hourly, minute, second for variation. Every moment there's an opportunity for things to change, and yet you have a continuous flow of, let's say, product leaving your operation. So those two topics become the theme of all of those different principles. And I think it's the understanding of those that is most important for really having a good grasp of what's important in manufacturing, whether you're doing it entirely manually or whether you're a full Industry 4.0 leader.
You mentioned that you have kind of the subset of the manufacturing master's program, which I think you call it the principles of manufacturing micromasters, actually.
Yes.
And just wanted to clarify, the principles of manufacturing is those 4 courses specifically, the business or management and engineering, process control, manufacturing systems, and the supply chain course, correct?
Right.
Yeah. So where do you think industrial IoT fits in with the principles of manufacturing? And if it doesn't, if it's more of just a supplementary piece, how do you think that it appropriately supplements those principles?
Well, the interesting thing I think about industrial IoT is that I guess the word I like to use is transparency. It's a matter of, if I think of IoT as being instrumentation, the ability to, or any sort of data gathering, the ability to really have reliable, repeatable, digitized data available on all aspects of the operation. So again, the way it relates to the principles of manufacturing is you want detailed, high bandwidth, high fidelity information from your processes. You want it from the product itself and the result of those processes. You want it from the factory, how things are flowing through the factory and what's happening with the interaction of the machines and with your buffers and with your inventory and other things like that on a real-time basis. And then just extend that outside the factory to understanding, at least to certain a number of layers, the same information about your inventory in the supply chain. So, I mean, for example, I think, Arjun, as you know, we've done a number of projects with our program on something like RFID. It's a breakthrough to be able to understand in greater detail what's actually moving through your factory and what's moving through your supply chain. So I think that I see those things as basically helping you execute each of those, each of the activities and the principles to a much higher degree of certainty, with much greater responsiveness, and of course, as a result, with much greater efficiency.
Absolutely. And, you know, bringing this back to industrial ML just for a second, I think that a lot of the way that we built this company technically was actually based on some of the things that I learned about the principles in talking to you for all these years. I think the original mission statement of the company was, you know, using machine learning, assuming that all the data was available, to unlock a new level of analysis for factories. And, you know, that I felt fit mostly into the process control space. As the company has grown and as our product has become a little bit more mature, I think that we fit pretty heavily into the systems principle as well, where because we're gathering data from as many different parts of the factory as possible, from sensors on the production floor, from enterprise IT sources, which give metadata about the parts being produced, video and audio sources as well. It becomes a lot easier to identify bottlenecks in your production process and be able to correct them, as you said, in real time. I think that, you know, finally, because we're also now, you know, able to convert production data into financial data, and that's not necessarily that difficult to do, we can augment the business principle of it as well. We do have some machine learning applications, and I think one of the ones I've talked about in some of my previous videos has been computer vision. But the ability to interpret audio communications is another one. I'm curious as to your thoughts as to how some of those machine learning applications, you know, I'll basically ask the same question. Where I previously asked, how does industrial IoT fit into the principles? Where does machine learning and some of those applications in particular, how do they fit into the principles?
Yeah, I think I want to pick up on the word you used earlier, which was analytical. One of the things that we try to impart is the idea that we define the problems in each of these areas, these principal areas, but in most of them, if not all, there are certain models, there are certain analyses, there is some math that can be used to allow you to make predictions based on information. You know, my area of expertise is at the process level, and as you know, with most manufacturing processes, in terms of true data as to the success of the process, you have to wait until things are over, and you look and see how it's done. And I learned about this the hard way, because at the beginning of my career, I thought we could do it all with some fast feedback control, looking at what's going on in the process. And that actually turned out to be really difficult to do and impossible for most processes. So I think the reason for that is that the modeling needs at the process level are very difficult to achieve with what I'll call classical first principles modeling, or even purely physics-based kind of discrete modeling. And there are many, and it has to be a process that is not a general model, but is very specific to the process at hand. And so it's something I always try to get across to the students in my process control classes. We're not talking about an abstract control problem here. We're talking about this machine, this product at this moment needs to do the right thing, and needs to do it often, as I say, at an error rate of parts per million. You know, so you want to do very well. So you need a very adaptable, specific model to use whatever data you have. I think machine learning has the capability of combining sources of information that we now have because of ubiquitous IoT, and combining it into much more specific models for the specific process, material, product at hand, and really holds out the prospect of a breakthrough, I think, in our ability to control at the process level. And now, again, as is always the case, if your expertise is in one area, you look at the other areas and say, oh, those problems are easy. But I don't mean to minimize the problems at the systems or other levels. But I do know that at the process level, it can have a significant impact in allowing us to relate what's happening upstream in the process to the quality of the product that's actually being produced in a much more timely fashion, a much more responsive fashion than we're able to do with our conventional methods.
And I mean, this is one of the things that even I would say I believed at the outset of industrial ML, which is part of the reason why we're named industrial ML. Yeah. But it's a prevailing view, I think, generally in industry and in a lot of segments of MIT as well. I should clarify that when I'm asking this, I'm only talking about my opinion and yours here. But the prevailing opinion is that machine learning can be the solution to all problems. And I think both of us have had enough experience to not necessarily feel that way. So could you expand a little bit on, say, some of the limitations that we have in machine learning and some of the requirements that are needed in factories in order to make it useful at all?
So I think certainty is very important in a factory. We're trying to reduce variation, and many machine learning techniques will maybe be able to help you make decisions to a greater degree of certainty on a discrete basis. When we talk about continuous control, like we're talking about with many manufacturing processes, I think I don't know, in my own experience, we're still sort of in our infancy of what techniques, where, and how well they will work. My experience with machine learning is very old, and back when I was working on arc welding, we used a little bit of neural network modeling, and the issue there, I guess, was really of the plethora of choices that you have with the model, which one was the best, and were you sure it would work under all circumstances? I think we've made a lot of progress on that in the intervening years, and of course, the biggest progress is that we have an incredibly inexpensive computing power and memory, so that we can do a lot more than we used to be able to do. So I am always leery of anything that says it's the solution, but I do think that the way I see machine learning being used a lot is, I guess there are two extremes. One is throw everything out that's been done before, and we'll start with a black box with data and machine learning. And the other is to work up against the limits of what our, let's call it, conventional non-machine learning approaches are, and then say, okay, how can we use ML to move us to the next level? What is it that we're not able to do right now? How can I improve my ability to predict what's going to happen on the output if I have a lot of information that I don't fundamentally understand how it relates to my outcome, but could make that relationship with machine learning. And so I think it can be very helpful in that regard. But again, I don't see it as something where you disconnect everything you've done before and then substitute this and all is well.
I know our mutual colleague Stan Gershwin, he actually wrote a paper about this, I want to say 4 years ago, about the role of intuition in manufacturing. And I mean, basically the point was you can't replace common sense by just throwing everything into an algorithm. I mean, and one of the things that I've noticed with other platforms, and they've had their own successes, so I'm not gonna name drop anybody, but it is a very common thing in our industry for people to say, hey, we have the best visualization tool, all you have to do is hook up your data. We have a suite of algorithms available, all you have to do is plug the data into it.
Yeah.
And originally I thought that would be a great way to build industrial ML in a way that's easily scalable. But it became very clear working with our development partner that there is a reason why I call us a data integration, analysis, visualization, and messaging platform, and not just an analysis platform. All of those things are critical parts of developing a complete solution for a customer. And I think part of the reason why I wanted to have this particular discussion with you is that I think that a pure analysis solution that has machine learning but neglects everything else really doesn't align with the principles of manufacturing all that well.
Right. That's right.
And here I'll pose another question to you about why do you feel that a lot of industrial IoT companies fail? And I guess the converse to that question is, why don't manufacturers adopt industrial IoT technologies to a greater degree than they have so far?
Yeah.
And I'll particularly weight that question towards how are they failing to apply the principles of manufacturing?
I'll dodge the first question because I can't really name companies that have failed, but
Yeah.
let's just say I like the idea that why have we yet to see the impact of IoT and machine learning in industry? And I think part of it is just what you said. I think just as frankly, the same thing happened when robotics was first coming in. It was hailed as a universal solution, and you didn't need to know the context. I think partly maybe this happens at the beginning of any new technology, and a lot of that changed over time. And I think a parallel is happening here, is that you have new methods. Machine learning, although it's been around for a long time, in terms of its actual utility, has only come to the front. I don't know, what would you say, maybe 5 years, 5 or 10 years in terms of commercial?
In terms of ubiquitous interest, I'd say 5 years. Obviously, it's been there for a lot longer.
Yeah, it's been there for a while, but it's taken many things plus the passage of time to have these things be successful. But I think the pitfall, when I see it, is just what you said. We know everything about analysis. Just send us your problems and we'll figure it out for you. We know everything about instrumentation. Just bring in our instruments and you'll be all set. I think what is missing is this real appreciation for the problems that are being solved and what are the actual data needs and the modeling needs. So it's the idea that there isn't sort of a plug-in black box that you can put on anything and it will take care of the problem. I think as we mature in this field, we'll get closer to those types of things. And I do, I now think about the whole area of automation, which now has a lot of much more plug and play type of characteristics than it did not too long ago. And that's because we have refined our understanding of the types of problems that can be solved. And I think the same thing will happen with machine learning. And that's why I have always liked the approach that you've taken with industrial ML. The idea that it should be, first of all, it should be something that is applicable to any company, but in particular applicable to smaller companies, where you need to have it be approachable and useful across the board. They're not going to say, well, we've got everything set, we'll just do the analysis for you or something like that. It's more like, I need a total solution, but it's a solution to a very specific set of problems in my company. And I think that's where we need to be in this whole field, to start to develop methods and tools that will then eventually become, I hope, a little bit more universal.
Yeah, I think a good way to put it is I think a lot of the existing tools are solutions looking for problems rather than solutions to a set of problems.
The old hammer looking for a nail. Yeah.
Exactly. So, I think one other point I'd like to make is we talk a lot about the four tenets of manufacturing: quality, cost, rate, and flexibility.
Yeah.
I think that I've often couched this as solution looking for a problem, or something where it's heavily reliant on the stakeholders at a factory to know what their problems are and exactly how to use a solution. I think there's also perhaps another abstraction that I can put in where, and I've actually heard this from our customer in the last from our development partner in the last couple of weeks, where, I mean, great, we have, alerting capabilities, we have pretty robust data display and messaging capabilities. But their stakeholders need to know how they can use all of those tools to solve the specific problems that they have.
Right.
And when it comes to things like not just how the product is developed, but how training and implementation procedures are done for an industrial IoT product, I think it is very common that companies just say, this is the technical capability that we have, instead of saying, these are the problems that we know that you have. And for instance, if as an engineer you want to understand what range of furnace temperatures allows you to run a steel tube line at 100 meters per minute versus 120, you'd want to be able to know how to use our platform to address that particular problem, not just say like, all right, I have to explore on my own how to do that.
Yeah.
I think that is a very common fallacy that I notice in our industry, where that particular training and implementation program isn't a part of it. And I understand why. Obviously, people in IndustrialML's position want to be as generic as possible so they can cater to as broad a range of customers as possible. But it does inhibit the ability to properly service a particular customer or a particular industry. And I think that's part of the reason, why we want to take an industry by industry approach to how we penetrate the market, instead of trying to cater to as many different manufacturers at the same time as possible.
Yeah, I think that's exactly the right approach. Again, maybe in the future, as more general solutions emerge from all of this, you can back off from that. But I do think that, you said it earlier, in some ways, the first question you want to ask of a customer is, what's your problem? What problem you're trying to solve? Which of these issues, obviously all of them, rate, quality, cost, and flexibility are key issues, but in many cases, there's a dominant one, and you would have potentially different solutions for those. And again, particularly at the process level, where physics is it's your savior and your enemy at the same time. You have to understand it. It's not there's nothing generic about it. So I think that idea of working with customers, having enough content expertise within your organization, as well as working with the experts at the company, is the best way to move this whole area forward.
So I know we're close to the end of our time. I'll just wrap up a little bit by saying thank you very much, Dr. Hardt, for having this discussion. I think it's been obviously very enlightening, and I look forward to doing more of these with you in the future. If people want to know more about the principles of manufacturing, or how MIT teaches them, where can they go to find out more information?
Well, the principles of manufacturing are, in terms of a curriculum, are very well described in the MITx program on manufacturing. So the easiest way to do it, I think, is if you search either MITx or edX for manufacturing, you'll come across several different entries, but there's one very specific to principles of manufacturing. it's a little bit of a marketing spiel. It's not exactly the whole thing. But within that program, which is, and those online classes are available to anyone, kind of free of charge, as long as you don't want a certificate or something like that. There is a short introduction which goes through the principles of manufacturing in quite a bit of detail over about a half-hour video. And that's the best place right now that I can think of to find a detailed discussion of that.
Thank you very much, Dr. Hardt, and I look forward to doing this again.
My pleasure, Arjun. Take care.